Hi students, finally we are in the last topic, okay, that is the application of Gauss's theorem, last one, electric field intensity due to a uniformly charged spherical shell. So, in some board question, along with the state and prove Gauss's theorem, shell question was asked, okay. Drawing also asked, one graph to draw the field due to a shell, inside the shell, on the surface of the shell, outside the shell, everything I will explain. So if you did not see the previous videos, all topics I completed. If not seen yet, please check my channel, you will see that one and you can learn from there. So electric field intensity due to a uniformly charged spherical shell. So there are two cases, one is field outside the shell, second case field inside the shell. So in this case, first we make the statement, okay. Consider a thin spherical shell of radius capital letter R. This time use capital letter R, compulsory, because point we are going to consider, we will consider for Gaussian surface, and small letter R we will use again. So consider a thin spherical shell of radius capital letter R and center O with charge plus Q distributed over the surface of the shell uniformly. So while drawing the diagram, you will understand what is the meaning of this statement. We are considering a shell of radius capital letter R, first thing is that one. Second, we are considering the charge is spread uniformly over the shell surface, okay. Also we mark the center of the shell is O. This much is written in the first page, and what is there on the surface of the shell? Plus Q charge is uniformly distributed. And what is the task here is, we want to find what is the field produced due to these charges spread over the surface at the point P, which is at a distance small letter r from the surface of the shell. So to calculate the electric field intensity at any point P, where is the point P located? Outside the shell. Imagine a sphere, such a type imagination is known as Gaussian surface, right? Imagine a sphere of radius small letter r, as shown in this diagram. This diagram going to make now clearly. It is not 100% spherical, but you make it is in spherical form, okay. While I am doing on this white, this digital pad, it come like that one. Okay, this is the actual shell where I marked red color positive plus Q charge, and the center of the shell is marking as O, and the point P is at a distance small letter r from the center, that I am marking first. The radius of the actual shell I am marking here, that is capital letter R, okay, that much done. Now at the point P, like the proof of Gauss's theorem, you remember, same task do. At the point P, consider a small surface ds, okay, and the direction of electric field at the point P also mark. Definitely that will be directed away from the shell, because positive charge is spread over the shell. Direction is always away from positive. ds also mark in the diagram, so that you can label it to the angle between ds and E is 0. Why 0? Because ds direction is normal to the surface of the sphere. E direction is away from the center of the sphere because of the positively charge. As a result, they become parallel, angle between them is 0. So the time when we apply cos 0, answer 1 will come. So according to Gauss's law, we are going to write, okay. It is a little bit similar to the Gauss's theorem proof. According to Gauss's law, or according to Gauss's theorem, phi is equal to, what is actually Gauss's theorem? The total electric flux over a closed surface is equal to 1 by epsilon 0 times the net charge enclosed. So phi is equal to integral E dot ds, okay. Closed integral E dot ds is equal to Q by epsilon 0. This is a statement of Gauss's law. Phi is equal to 1 by epsilon 0 times Q, or phi is equal to Q by epsilon 0. And in terms of integration, E dot ds also can come. Now this is the time to fill up, okay. Phi is equal to closed integral, phi is equal to E ds cos 0. Cos theta actually, but theta here is 0, so cos 0. You know that cos 0 answer is 1. So what is there in the equation now? Phi is equal to integral EDS will come. Okay. Or right side I forgot. Q by epsilon 0, because we are writing Gauss's law, right? Right side is equal to 1 by epsilon 0 times Q, that is Q by epsilon 0 labeled now. Now integral E dot ds, we can write E is outside the integration because E is a constant. E integral ds is equal to Q by epsilon 0. Now we got the place for integral ds. In the case of sphere we used before. In the case of sphere, the total surface area of the sphere will be 4 pi r square. So E 4 pi r square, because integral ds is 4 pi r square. E 4 pi r square is equal to Q by epsilon 0. And right side I am giving the reference, total surface area of a sphere is. What is total surface area of a sphere? Integral ds is equal to 4 pi r square. Actual equation is 4 pi r square. And the radius is small letter r, so maintained well correctly. So E 4 pi r square is equal to Q by epsilon 0. Since we are looking for what is E at point P, E is equal to cross multiply Q divided by 4 pi epsilon 0 r square. 4 pi epsilon 0 r square. This is the electric field produced at a point P outside the shell. Okay, due to a charged shell. Outside the shell. Inside the shell is coming. This is applicable for outside the shell. So see, I am just underlining to show you like that it is actually outside the shell. Now what we do next? The last topic of the lesson, that is electric field at a point P which is inside the shell. Okay, inside the shell. Let's start now, or you need a break? What do you feel? You can start, right, so that we can relax. So B, that is the part 2. Outside the shell is, point outside the shell is section A. B is the at a point on the surface of the shell. Oh, I forgot to tell you. Third option possible, outside the shell, inside the shell, on the surface possible. This is for on the surface, okay. At a point on the surface of the shell. Why we required on the shell? Because there was a graph. Board question was there. Plot a graph showing the variation of electric field inside the shell, on the shell, outside the shell. So this is good. So the section B, at a point on the surface of the shell. So that is easy actually, no much work. At the surface of the spherical shell, the point P distance small letter r is equal to the capital letter R, radius of the shell. Yeah. So small letter r is equal to capital letter R. So E is equal to, we can copy that above equation, derivation already done, right? So E is equal to Q divided by 4 pi epsilon 0 r square. Okay. So we can put a square on that one, that is make it in the box. Done, work finish. So Q by 4 pi epsilon 0 r square. So electric field purely depends on r square value, because Q 4 pi epsilon 0 everything is constant. Okay. I'm just little slow now. Wait. If sigma is the surface charge density, you know other surface charge density, right? One is the linear charge density lambda, other one is the surface charge density sigma. Actually we are considering the surface of the shell. So surface charge density is always sigma only. So if sigma is the surface charge density on the shell, then what we can write? One extension to the topic what we are learning, okay. So can you see the equation? Actually E is equal to Q by 4 pi epsilon 0 r square, right? We are planning to do some modification now. E is equal to sigma by epsilon 0. You can apply that one actually, and you can extend. So from the above expression what we can conclude is E is equal to sigma by epsilon 0. Yeah. And is a constant. Why this is a constant? Sigma by epsilon 0 is a constant because sigma is surface charge density and epsilon 0 is already a constant. So if sigma, if you consider that much, then you can write the expression as shown above. Okay. The third component here is, see, point outside the shell we considered, point on the shell we considered. Now third we are going to consider electric field inside the shell. In this topic, last topic, inside the shell, actually some people teaching like inside the shell there is no charge exist, so there is no flux exist. It makes sense, answer become in seconds, but we are preparing for board examination, right? In the examination, the one who is correcting your paper will have a printed or a soft copy of the answer key. Okay, there will be an answer key. If you are not writing sufficient statement for answer, there is a chance of losing mark. So I suggest you to write sufficient statement for each answer. So in this case, the case where electric field inside the shell, you write the statement like what I wrote here. To find field at a point P inside the shell, consider a Gaussian surface of sphere S2, simply labeled S2. This imaginary sphere is inside the existing sphere, okay, inside the existing sphere. So to find field at point P inside the shell, consider a Gaussian surface at a sphere S2 passing through P. Okay, that is the point P is considering inside the original shell, and imagine a Gaussian surface is there at the point P in the form of a sphere of radius small letter r and center O. Here you know that small letter r is less than r because the point P is inside the shell. Yeah, inside the shell. Draw one diagram now. First do a sphere, original one, okay. Original one, the sphere radius, what we can write, capital letter R. Imaginary one, that is inside in blue color, that radius we can label it small letter r. And where is the charge located now? Charge is spread around the original shell of radius capital letter R. Okay. Original shell radius is capital letter R. The charge is spread over that one. And imaginary one is point P touching sphere, that is small letter r. So diagram you see, small letter r I did labeling, capital letter R also I did labeling. Okay. Now the time to go to the equation. We don't have much steps in this case because you can look into diagram and understand there is no charge exists there. There is no charge exists. Okay, let me write first. Okay. You complete the things the time when I write, you note down the points, each points. The reason I am writing now, why there is no flux exist in this scenario. At the charge, as the charge inside the spherical shell is 0, look into diagram, charge exists or not? No exists. As the charge inside the spherical shell is 0, the Gaussian surface encloses no charge. Clear, yeah? This statement is enough to give the answer actually. As the charge inside the spherical shell is 0, the Gaussian surface encloses no charge. If no charge, in the equation the place of Q will be replacing with 0. So what is going to be the flux is 0. So by definition, by Gauss's theorem, you can say total electric flux phi is equal to integral E dot ds perfect is equal to Q by epsilon 0. That is the standard equation. But in our case, Q is 0, correct? Q is 0. So E is writing outside. E integral ds is equal to, actually is equal to Q by epsilon 0. Is equal to Q by epsilon 0. But you know that there is no charge exists. There is no charge inside the spherical shell. As a result, what is going to be to the final answer is, it is going to be 0. Okay. This part little slow, right? So phi is equal to E. Why I wrote 4 pi r square? Because the total surface area of a sphere of radius r is 4 pi r square is equal to 0 by epsilon 0. You noted that one? I wrote is equal to 0. Why 0 by epsilon 0 I wrote? Because q by epsilon 0 is the actual things. But we mentioned above, right? The Gaussian surface don't have any charge. So q is equal to 0. So total surface area integral ds is 4 pi r square, and q here is 0 inside the shell. So what is the final answer now? Flux exists or not? No exist. That's all. That is the last topic of the lesson. There is no flux exist inside the shell, but there is a flux exist on the shell. There is a flux exist outside the shell. So outside the shell flux exists, on the shell flux exists, but inside the shell no flux exists. Yeah? Anything else? And definitely you will have some doubts related to all the topics. All topics I finished from chapter number 1. If you get a doubt, you post the comment below the video. I will try to read and answer in the form of video if it is a new topic or something like that one. Okay. So is equal to 0 for a case where small letter r is less than 0. Hence, we can write the conclusion, then we can end the video. Okay. What is the statement I am writing is about the point inside the shell. Okay. Hence the electric field inside the shell is 0. Okay. Hence the electric field inside the uniformly charged spherical shell is 0. Writing taking time, not like expression actually. Text writing is a time consuming job. Look into the diagram. This question asked once, okay? Not once, more than once asked in the board paper. What is this one is? This is showing the variation of electric field for a charged shell. The point outside the shell, on the shell, inside the shell. That is the graph. I am just marking, observe clearly. See 0 to the surface of the shell, there is no field, so it is along x-axis. At the surface of the shell, the maximum exists. So suddenly draw a line upside. From there it start reducing as the distance increases. If the point P is far away, slowly it vanishes. So E is inversely proportional to 1 by r square, you can write. From this graph, E is proportional to 1 by r square, you can write. So a quick revision, a plenary we can say about the video. As this is the last video, I would like to show you that what are the topics covered. See electric charges and the conservation of charge, Coulomb's law, force between 2 point charges covered in part 1. I did not mention like a part 1, but there was a video which covered this much. Then in the second video of the lesson, forces between multiple charges, superposition principle and continuous charge distribution covered. Okay, second video of the lesson. And third video, electric field due to a point charge and electric field lines covered. I remember that one. So in third video, this much part covered. In all the videos, if possible, I included the numerical also, okay. But numerical is coming, don't worry. Now I am focusing on completing the lesson lecture. After that, all board question will be covered, don't worry. Then in our next video, electric dipole, electric field due to a dipole was there. There are two videos actually, because electric field due to a dipole along the axis, perpendicular axis, 2 time axis. So 2 videos I made. and this one torque on a dipole in a uniform electric field, one video made. Okay. Next, electric flux, statement of Gauss's theorem and proof, one video was there. Electric flux, statement of Gauss's theorem and proof, one video was there. Then the application of Gauss's law, electric field due to a infinitely long wire, one video is there, and electric field due to a uniformly charged infinite plane sheet, another one video is there. And the third one, what is going on now, uniformly charged thin spherical shell, that is field inside and outside, another one video is there. So it covered all the topics of the lesson. Which channel you can see like this one, I teach like you are my children and you are my students, so I consider maximum. Okay, still you can request the numericals, I can help you. So all topics are covered. I hope you are happy. If you are happy, this is the time to share my channel with your friends and help me to grow the channel. I expect your cooperation. Okay students, thank you, have a nice day. I am also happy. Lesson finished, right?